Continuing on in section 3.5, we've seen box plots, so now we want to be able to judge the shape of a distribution from a box plot. Now this is a rule of thumb. This isn't going to be exact, so there are going to be box plots that aren't going to fit this perfectly. But in general, if a distribution is skewed right, also known as skewed positively, because the positive side is where the tail is on the high right side, then that means that either the whisker is going to be longer on that side or the box half is going to be longer on that side or larger on that side. Symmetric is going to mean more or less that they're pretty equal, as this one is. And skewed left, aka skewed negative, is going to have a longer whisker on that side and a longer box on that side. Now again, this isn't perfect. This is just a rule of thumb for looking at box plots. If you want to know if it's really skewed, you can look at a histogram, and there's also something called a skewness coefficient that we're not going to deal with in this course, but there are other ways to judge skewness, quote unquote. All right, so let's look at our box plot from our test data. That was the algebra exam data. Here was the one that was created in StatCrunch. Here's one from Minitab, and here's another one from Minitab. It's all the same data. Now you can see this is a little bit confusing here because the box on the right is a little bit larger, just a little bit. But the whisker on the left includes the star. Always remember that it includes stars over here. They're part of that whisker. So if you take that into account and see how long this whisker is compared to how short this whisker is, that trumps everything, right? So you have this outlier down here, 58, that's making it skewed left, right? Because that outlier 58 is making this whisker here really super long. The box part is a little bit bigger on the right, but that's not going to win out over this huge whisker. So this is skewed left. Now you notice I'm making a kind of a judgment call there. I mean, it's not a hard and fast rule, but you want to look for the more dramatic change, right? So if the whiskers were both the same and the boxes were uneven, you'd look at the box. If the whiskers are uneven and the boxes are equal, you look at the whiskers. You're looking for unevenness, right? And the whiskers, here, let me put this in here. The whiskers are very uneven. So they're going to win out. And the one on the left is much bigger. Much bigger because of outlier. That outlier star counts as part of that whisker. All right, now once we know that it's skewed, what's the best measure to report for mean, for center and for spread? Would that be the mean and standard deviation together, or the median and the IQR? Well, let me find that. That was an earlier concept. Hold on. Here it is back here. When we first learned about IQR, we learned that if your data is symmetric, you're better off with the mean and standard deviation. Okay? But if it's skewed left or right, you're better off with the median or the IQR, the interquartile range, because they're both resistant to that skewing. So if that's the case, then for our particular data set, we'd be better off with the median and the IQR because they are resistant to the skew that this data has. Skewness of the data. That's a word. All right, now this is the box plot for the U.S. export data we've seen several times in Chapter 3. Now the first question is, what is the shape of this distribution? Now remember, the low numbers, right, are down here. The high numbers are up here. And you can see that we have a super long whisker when you count those three outliers, which, by the way, that's the answer to this question. I kind of have this out of order. All right, so there's three outliers, right, the three stars. And when you count those as part of that whisker, this is very much skewed positively, or positively skewed, aka skewed right. Right? Because the large whisker is going to the high numbers. All right, that's done with that. Now, let's see. This box plot shows the percentage of high school seniors who participate in taking SATs varies from state to state, right? So some states have a lot of students taking the SATs. Some students have very few taking these SATs. So, for example, 10% of high school seniors in Alabama take the SATs, and that's in the ESC region. So I have all the different regions here. These are the U.S. Census regions: East, North, Central, East, South, Central, Mid-Atlantic, Mountain, New England, Pacific, South Atlantic, West, North, Central, and West, South, Central. Ooh, so many of them. But those are the U.S. Census regions. So here they are. And you can see the participation in the SATs from state to state. All right, so first thing we want to know is which region has an outlier? Well, that's rather obvious. There's only one star on the board, and it's this one right here, and that's the SA region, South Atlantic, SA. What is its value? Looks like it's about 20 or so. 20%, because these were all percentages. So 20% or so. What does that imply for that region? Well, almost all the states, but one, if you look at the South Atlantic, almost all of them are up in the high, what is that, 65 and higher, are above 65% for SAT, or for taking the SATs. But one state is only at 20%, right? In that region, I should say. One state in that region. Okay, now which region has the largest range? Well, okay, well, we can knock some of these off right off the bat. ESC is out. That's really short. MA is out. That's short. Mountain is out. That's short. I mean, this ENC one's pretty long, so I bet you he's in the running. ENC is larger than WSC, so that's out. So right now, ENC is the winner. But there is a little bit of a trick in this question, because there's one other that has the same range, if you will, and that's SA, South Atlantic, the one we were just looking at. See, South Atlantic's high is at 80, and its low is at 20. 80 take away 20 is about 60. And if you look at this one, ENC, the high is at 65, and the low is at about 16, or 65, or 66, I should say. 66 take away 16 is 40. Excuse me, 60. I'm being possessed. So this one's got 60, ENC is 60, and SA is 60. They're both about 60. So the two of them both count for the largest range. There we go. All right, so ENC and SA. Oh my goodness, here. Both are about 60% range. We don't know exactly, but they both look to be about 60. SA is a little bit of a trick because you think SA is not as big, but then you remember that the star counts as part of SA. So that outlier down there. All right, which region has the largest participation rates? Okay, well, that's obvious. That's MA, right? The Mid-Atlantic region. They're very high up there, right? So MA. What is the Q3 for the West South Central? Okay, so West South Central is over here. Now remember how it goes. Bottom of the whiskers min. First line is Q1. Second line is Q2. Third line is Q3. And the top of the whiskers the max, right? So that Q3 is right there. That's what they want. So it looks like maybe 43 or so. Okay. About 43% participation. All right, what about the East North Central? That's where Michigan is, by the way. Michigan being the state where I am right now. So let's see. Median. Median's the middle line, right? Well, that's about 10%. Yeah, Michigan is not a SAT state. We're an ACT state. Although not all of the states in our region are that. So our state varies a lot. So there's some state in our region that's 65%, but there's some state in our region that's, what, 8%? 7%? Somewhere in there. All right, what about the IQR for the mountain region? All right, mountain is right here in the middle. So its high number's about 32 or so, and the bottom number's about 12, right? Q3 is the top of the box. Q1 is the bottom of the box. So that'd be 32 take away 12, which is 20% or so. All right, the next page is the same box plot. It's just I didn't want to have to make us all repeat. So it's the same box plot, same problem. So what percent of the ENC schools, East North Central, are between 10 and 47? Okay, so East North Central is over here. Now remember how this works. Every single section of this has 25% of the data. So 25% of the states are in that little whisker, 25% are in that first lower bottom box, 25% are in the higher part of that box, and then 25% are in the whisker up here. So between 10 and 47 would be 25%. Right, because each section of a box and whisker plot is worth 25%. Now what about West South Central? That's between, what is this, or above 42. 42 is, here's West South Central over here. 42 must be about Q3. So above that would be just that whisker. Well, each whisker is worth 25%. So that's 25%. Now, several regions appear to be missing whiskers. What's going on with that? Well, look at MA. See right there with MA? So what's happening there, so for example, MA has no whisker. Just to give you an example of what to look at. Okay, so why is that happening? Oops. That happens when the minimum is equal to Q1 and or the maximum is equal to Q3. That can happen especially when it's a small data set. So for example, if we look at MA for a second, suppose it was, what is that, 72 or so? 75, let's say that's 75. So if it was 75, 75, 75, and then the median was, looks like 87 or so, 86 maybe, and then the top was 90, what is that, 92? Here, 92, 92, 92. I think that's where the top end is. Yeah. So if that's the case, then your max is 92, but your Q3 is also 92. So, and then here your min is 75, but your Q1 is also 75. So it ends up being that they're all kind of the same thing, right? So that would be how MA would have no whiskers, right? Where your Q1, which in this case was 75, was equal to your min Q1. And then your max 92 is equal to your Q3, which is also 92. So that sometimes happens. It's especially common. This is especially common with small data sets. There's only 50 states, right? So once we've sectioned them into this many different regions, there's not a lot for the MA. There's only a few states there, right? All right, now what does this graph reveal about participation in the SAT in the U.S.? Explain. Well, that's the interesting part. I mean, all the rest of this has just been analyzing this graph, but what does this really show us? And it shows us that popularity of the SATs really varies a lot from region to region. So let me type that up. Hold on. There we go. So popularity of the SATs really in the U.S. really varies a lot from region to region. And number two, you can spot that the SATs are by far the most popular in the Atlantic regions. So on the eastern seaboard, there's your mid-Atlantic, right? That's like, you know, Maryland, you know, your South Carolina and stuff, and actually probably North Carolina. And then the South Atlantic region, that's your Georgia, your South Carolina, and so on. And then your Northeast region, that's your Maine, and so on, right? Maine, Massachusetts, New Hampshire, all that. So those three regions are where it is by far the most popular, right? Now, I got to keep in mind for you, for these last questions, this is really more you analyzing these graphs. There's a lot of right answers. You could talk about how unpopular it is in the East-South Central region or the West-North Central region. You could talk about, you know, it really varies a lot from state to state, but the regions tend to be very similar except for these two regions, East-North Central and West-South Central. SA is kind of different because it has everybody in the group in one cohort except for this one state out here. Who the heck knows which state that is? There's a lot of right things you can say, and you're trying to analyze it and pick out some big important points. So there's no one right answer for this. All right, I'll see you back here for more videos.